Hello guys, this stream is just for testing. In this stream, I am going to write a program of binary search. You must have heard of this. So, in binary search, what we do is if we have to search any element in an array which is non-decreasing, we can get it easily by binary search. We can get it also by linear search, but binary search is more efficient. It can, as it can give result in log n time. Otherwise, linear search takes it linear time to search any element in a non-decreasing array. So, how does it look like? Let's see it. So, we have taken an array which has 7 elements, and let us take our key element which we are going to search as 578. So, what our program will give? It will give the indices it will give the indices of the key which we are going to search. So we already know our answer. Our answer is 0. Our answer what is output? 1, 2, 3, 4, 5. Our answer is 5. So how do we get it? Let's try. So let's make a function of binary search which will return indices. So I oh, sorry, I've given space. So what we will take as input. So in input we will take what we need to take is array and the key element. So that's all what is required. Now we create two pointer, low and high. Low will point to 0 and high will point to the indices, the last indices which is 678. So what's the last indices? Oh, it is 1. So it seems that we need one more variable size to put it in high. So high, where will be high? So its size is 7. So it will be size minus 1. We keep it as size minus 1. Now our search space lies between indices 0 to size minus 1, that is 0 to 6. And what we do in binary search is that we at every step we eliminate one half of the search space. So what I mean that here we have 7 elements. So in first step we will eliminate half. So what's half? Either we will eliminate 4 or 4 element, or either we or 3 element. So it depends on the data which is in the array. So let's write this program. While low less than equal to high, so we will create a variable mid. So what is mid? It's nothing but mean of the low and high. So at each step we will see if array of mid is greater than the key element or not. So if array of mid is equal to key element, then it's sorted. We will directly return the key, which is nothing but mid. So there are two more cases. If a array of mid is greater than key. Now tell me what we will do now. If array of mid is greater than key. So what will be our array of mid? 0 plus 7 by 2, which is 3. So 0, 1, 2, 3, 89, and which is less than key. 89 is less than 578 in this case. So what we will do? We will eliminate the left search space. Why? Because we know that our key element which we are searching lies on the right half. So we will eliminate the left half. It's easy. So I've written it wrong. So if air, sorry, let's write it correctly. The area of need is less than key. Then what we are going to do is that eliminate the left half. So how we will eliminate the left half? See, our low is this, high is this, mid is 89, and we know that our search space further will be this. We don't need previous 4 element because our answer will not lie in this 4 element. So how can we eliminate this? Since our mid is this, we will move our low pointer from 0 to high mid plus 1. That is, low will shift from 0 to this. That is 0, 1, 2, 3, 4, 4. So we will change our low to mid plus 1. In this way, our search space now is this. Low being at 4th index and high being at 6th index. Now, what is the other case? We don't write to need we don't need to write the condition because it will take care of it. Uh, if I need to say it is array of mid is greater than. So what we will do in this? We will give I as mid minus 1. I, because if we get if we get imagine what if we have made as 678, then what our search space lies here. So what we have to do? We have to move our high pointer to mid minus 1. So it seems right. And if we don't get any, if we don't get any result, we don't our if our key element does not exist in the array, then we will return -1, indicating that it doesn't exist in our array. So it seems good. Let's try it. So we will call we will store it in an integer. We'll call, so we're passing our array, our key element, key, and size of the array, that is 7, and let's print it x, and let's see call if it's written correct, then our answer should be what? 5, 0, 1, 2, 3, 4, 5. Let's see we get let's see if we get correct answer or not. You can see we have got the correct answer. So we have written the correct program. So this is the binary key, which is faster than linear key, much faster. If we have very high size, let's say 10 to the power 9 search space, when then in linear search we might end up solving this in more than 1 second, but in binary search we can do in very few milliseconds, because it can trim down in every space. It trims the search space to half. So in 30 20, 30 to 40 steps it will easily do the required steps. It will easily search it. So this is the binary search. So stop. Now I stop streaming. Let's see what happens.